What we're going to try to show in this demonstration is the ability of this alternator powered coil system to power a bipolar Tesla arrangement. What we're going to do first is we're going to turn it on, then we're going to increase the voltage 3 times. On the third level we should be able to see the power output being enabled to power the bipolar Tesla coil system, which is over here. We've done these demonstrations before, but things get screwed up because of the explanations. What we have here, if you'll see this checkers, the white checker is phase 1. It starts out as that taped coil, and it proceeds down to that middle taped coil, and then that's shown on the stack as the white, and then on the third series of its segments put on the alternator and resonated, it's on the bottom. Likewise, the blue does the same thing, and so does the red. The directions of the interweave spirals are against the phase rotation. Now those are all the preliminaries. We call that a 666 system because it focuses 6 polar areas at 60 degrees of a magnetic field separation, thus expelling the magnetic fields and repulsion to the outer winds. Now that we've explained this, or tried to, we're going to get to the actual work and turn the machine on. I'm going to go in there and turn the machine on, and here's our back 3 meters, or our stator line amperages. This meter here shows what phase 1 and phase 3 will consume, etc. on down the line. And on the other side over here, on the other side of the system, we have the appropriate measurements of the stator voltages. And I think we'll just go ahead and turn it on now and see what our stator voltages are without a field. Without a field, we have 0.7 volts on phase 1, 0.9 volts on phase 2, and we don't have phase 3 marked. It's 0.7 volts. We've got a lot to get through here, so we're going to quickly proceed over here and look at the amperages and how they're being divided. And we have 0.59, 0.52, and 0.53 amps. And then we have underneath that the stator line amperages serving the phases at 0.323, 0.309, and 0.350. Now we're going to go ahead and turn the field on at a 2 volt level. Volt field, we're obtaining an average of 3.4 to 3 amps on the stator lines and the respective amperages underneath. This is not real important. Over here we see that our stator voltages have gone up 5.6 volts on phase 1, 6.5 volts on phase 2, pardon me, enter too many things at once. And then on phase 3 we have 5.3 volts. Now what we're going to do is we're going to look on the loading and our loads. These are going to be our loads, them 2 high induction coils. Each of them high induction coils have amperage meters on them. And we can see there for some ungodly reason, which I did not expect. Well, we got 0.33 apparently we got 6 milliamps on the front inductor and only 0.3 on the back. I don't understand why that's happening. They shouldn't be receiving any signal that far from the system. Since we're trying to get through all this within 15 minutes, what we want to show next is what happens on the loading of the system and how it occurs. We're looking at now on phase 3 we got about 2 amps. There's the phase loading of our system. And the amperage it's consuming. As soon as we put the inductor on there, we should be able to note a drop in the input amperage of the phase that it's drawn on. Works in reverse to ferromagnetic. Works from the principle of vibration. The impeded vibration, the source of the amperage issuing that vibration will be reduced. So we know that the back coil is phase number 2. So we're going to put one of them inductors on phase number 2 top, and notice that it loads down the next phase in the phase rotation, which is phase number 3. Currently, phase number 2 has 1.79 amps, 77 amps, 0.17, and phase 3 has 1.9. Now we're going to place the inductor on the top of phase 2. We will note, placing that inductor on top of phase 2 has reduced the vibration on phase 3. It will always reduce the vibration of the coating made from the center coil of the stack, which is reversed to provide the 60-degree polarity. So we have that now. Notice on our phasings that we've reduced the vibration on phase 3. It's down to 0.5. The other phases are 2 and 1.5 amps. Now we're going to impede the vibration in the next phase. Did that. This is going to be the maximum load that we're placing on the system. And we got 0.9, 0.5, and 0.7 some amps on the unimpeded phase 1. There's our 2 inductors across placements. And here is our amperage readings for those inductors. 115 milliamps is being withdrawn from the back one. 157 milliamps is being withdrawn from the front one. Now we're going to go in there and turn the voltage up by eliminating some of our resistive ballast to field. And it will help now. We will look. We want to make sure that we're not exceeding that 200 milliamp level. Of course we are. We now have a quarter of an amp and 170 milliamps being taken out from the secondaries. We only got one more step to go. The back bulb's a xenon bulb. Right now it has 170 milliamps. Every milliamp across these 7,000 ohm reactances is equivalent to 7 volts. So right now there we have 170 times 7, and it's not lighting any of the bulbs. On our final step, we're going to light the bulbs now, but let's look at our input parameters real quick. We now have 11.4 volts. Pardon me again. My camera work. We have 11.4 volts on phase 1. We have 13.9 volts, as I can't see. 13.9 volts on phase 2. And phase 3, we have 12.2 volts. The next step, we're going to eliminate all the ballasting on our 7-volt field supply, and this should enable the xenon and the krypton bulbs to light. And then we're going to come back here again and start off from what those amperages are. Now when we increase the voltage, the bulbs will light, and hopefully our metering won't blow a fuse on that left-hand meter, since it shouldn't go over 200 milliamps, but the bulbs will light in this case, so we'll go ahead and go to the fullest voltage, 7-volt field. Now in a full 7-volt field, and notice that the amperage circulation in our secondary inductors in fact went down, but in fact they're powering loads. So there's the xenon bulb in the background, and the krypton bulb in the front. And this will be enabling us to power Tesla coil system wirelessly. We'll go and lift them coils to demonstrate that. That the bolt discharge went crazy above there, and we have to figure out whether we got the appropriate capacity for resonance, and we got to close this out real quick. Note our input stator line amperages in conjunction with our phase amperages. These need to be noted for comparisons of acting phase angles. And over here finally then, we're now at 18 volt level on phase 1. Phase 2, 19, and phase 3, 16.8.